Some more examples of definite integrals being used. Let's say that we were given this graph of dp dt, or you could say it was just p prime of t. Either way. And we knew one point on the original, p of 0 equals 2. Suppose someone said, well, I want to know what's p of 1, or what's p of 2, or p of 3. We could go all the way to p of 5. As long as you can find the areas on this graph, we can figure out what these values are. So, let's start with p of 1. Well, I know p of 0 equal 2. So, if I actually look at the area from 0 to 1, this area right here, I know that that represents the net change in my p. To look at it really, let's say that we started with, and in fact this might make sense with bunnies. At time 0 we had 2 bunnies. Alright, well I want to know how many bunnies do I have at time 1. Well, I know it. My p of 1 will equal my starting amount of bunnies, which is 2. And then I'm going to look at the integral, the change, from time 0 to 1 of my p prime of t dt. This integral right here represents the net change in the function p from time 0 to time 1. This integral also represents this area, except that since it's below the x-axis, it's not really the area, it's going to be a negative area. So if I actually look right here, this is a square. The base and the height are the same thing, 1 times 1, so it's a negative 1. So this is 2 plus a negative 1 equals 1. So at the end of, let's say, 1 hour, something really sad happened and I lost a bunny. I went from 2 bunnies to 1 bunny. Well, now I can actually figure out what p of 2 is. My p of 2 will equal, and I can start wherever I want. I can start here with my start amount. Let's say that I want to say I'm going to have a starting amount of 2, but now I'm going to look at the net change from 0 to 2. This will give me the ending amount at 2. I could also said that this is really just going to be 1 plus the net change from 1 to 2. So I'm going to start here instead of p prime of t dt. Either way, I should end up with the same answer. So if I integrate from 1 to 2, I'm very sad to say that we have lost another bunny, because this area is a negative 1, so the net change from 1 to 2 is negative 1. So I started with 1 plus a negative 1, and I am down to 0 bunnies, which begs the question of what in the world could have happened here. If I look at my net change from 2 to 3, that comes out to an area of 1/2, but it's negative. So somehow at time 3 I have negative 1/2 bunny, which I think means a zombie bunny. But it seems to work out in the end. I think someone got the bunny, because if you look at from time 3 to time 4, my area is 1/2 again, but this is a positive. So I think the zombie bunny went away. We're back to 0 bunnies. From time 4 to 5, the net change will be this area here, which is again a 1. So we've gained back 1 bunny. So from time 0 to time 5, we had a net change of negative 1, with some interesting things going on in between. But you can see if you have a start amount and you have the graph that you can find areas underneath the curve, or above the curve in this case, then you can actually figure out other values on your original graph. So let's take another example and look at this. Suppose you have the graph of the derivative, and I'm going to keep bunnies out of this. This is just f prime. Okay, they gave us the graph of the derivative, and we know one value in the original function. So f of 1 equals 4. So that was on our original function. Something they might ask you is, okay, what are coordinates, x coordinates of relative extrema? So we're looking for relative maxes and mins. And you've done this before. We know that a relative max is when the derivative f prime of x changes from positive to negative, above to below, and that doesn't actually happen. We go from left to right, so we have no relative maxima. A min is when f prime of x changes from negative to positive, and that happens right here. So we know that there is a relative min at x equals 0. And if I was asked to justify it, I'd say f prime of x changes from negative to positive. Now, that's not to say that there's only one critical number. At this graph, there are actually two critical numbers. You have x equals 0, and you have x equals 3 right there. You have two critical numbers, but because the sign of f prime doesn't change, this cannot be a min or a max. So we have one relative min, no relative maxes. Okay, well, what about absolute maxima, an absolute max and an absolute min of f of x? Well, I know that that can actually happen at critical numbers and at endpoints. But in all honesty, I already know that this isn't going to be one of them, because an absolute max will either happen at an endpoint or at a relative max. There are no relative maxes, so I'm going to have to check the endpoints, -2 and 5. An absolute min will take place either at an endpoint or relative min. That's right there. So I've got 3 places I'm going to have to check. So the candidates are, let's see, we're going to have to find f of -2, f of 0, and we're going to have to find f of 5. The highest number we get will be the max, the lowest number will be the min. All I know is that f of 1 equals 4. So I'm going to mark that on my graph right here. That is going to be my start amount. So I'm going to start by going to the right, keeping everything normal in my world. I'm starting here and going that way. So I'm going to figure out what f of 5 is. Well, my start amount is actually 4. At time 1, I had 4 of something, whatever it is. But I need to get to 5, so I need the net change from my start of 1, and these two will always go together. Your start amount with your starting time, or it's rather my starting y value at my starting x value. And then I want to know here. So I'm going to integrate from 1 to 5 of my f prime of x dx. So this will equal 4, and then I want to find the area. It's bound by my curve, the x-axis, and the lines x equals 1 and x equals 5. Well, this is a semicircle right here, and they would have to tell you that, so I'm telling you that. You have a semicircle, so it's the area underneath the semicircle and above the x-axis. Well, I can find that pretty easily by actually just finding the area of this whole rectangle and subtracting out the semicircle. So this rectangle has a base. We're going out to 5 starting at 1, so it's a base of 4 and a height of 2. So it's an area of 8. So this will be 4 plus 8, but then I have to subtract the semicircle, so that is a 1/2 pi times my radius. If this is 4, my radius is 2 squared. So this will equal 12, and then this is 2 pi. So that's one of my values. I still have to find my f of -2. I have to find that, and I have to find f of 0. Well, for f of negative, let's do f of 0. So my starting amount is going to be the same starting, so it's 4, plus I'm going to integrate from 1, again these two go together, to what I want, which is 0, of my f prime of x dx. Well, I don't actually like doing this because I'm integrating in the wrong order. You could do that, or you could just change it 4, and then I'm really going to change the sign to integrate from 0 to 1 of f prime of x dx. Switch my limits of integration, change the sign. So I'm finding the area of this triangle. It has a base of 1 and a height of 2. So it's 1/2 base times height. So this piece right here is 1/2 the base of 1, and the height of 2. So it's really just a 1, and f of 0 equals 3. If I actually want to figure out what f of negative 2 is, I'm going to actually use this as my start amount. I have 3 plus the integral from 0 to negative 2. Or I could say that I have 3 minus the integral. So I'm going to do that. I'm going to switch it. 3 minus the integral from negative 2 to 0 of my f prime of x dx. Now from negative 2 to 0, this is actually a negative value, so I'm going to end up adding a number in here. So it'll be 3, and then the area of this triangle is 2 times 4. 8 divided by 2 is 4, so 3 plus 4 equals 7. If I look at my numbers, I have 3, 7, and 12 minus 2 pi. So I need to figure out which number is the greatest. Well, pi is a little bit more than 3, so 2 times a little bit more than 3 is a little bit more than 6. 12 minus a little bit more than 6 is definitely less than 7, so this is my max. But it's not as small as this, so the 3 is my min. And I'm done with the problem.